Dear students, now today we are going to discuss about sequence. So you know the sequence and series from your school level. An ordered set of real number a1, a2, a3 up to an is called a sequence and is denoted by an. Okay, if the number of term is unlimited, then the sequence is said to be an infinite sequence, and an is its general form. Like this, just to remember, you have already gone through all such sequences, like finite sequence 2, 4, 6, 8, 10. If you this is the finite number of terms, but infinite, if there is, you don't know how many number of terms you are going to write. This is dot dot. This series go to infinite. And finite sequence, similarly, this is the alternate series. Minus 1 power n means one term is positive, another is negative. This will depend upon the value of n. If n is even, then positive. If n is odd, then negative. Similarly, but if this is terminated, then you can say this is also a finite sequence. But if it is non-terminating, then this is your infinite sequence. Now, the simple example sum. Let us suppose this example, it is very clear. Write the first five term of the infinite sequence, and sequence is given an is equal to 2n minus 1. So just you put the value of n, that is a1. A1 is of course 2 into 1 minus 1, that is 1. Similarly, a2, a3, a4, a5. Therefore, the first five terms are 1, 3, 5, 7, 9, and the sequence is 1, 3, 5, 7, 9, and so on. And the nth term of this sequence is 2n minus 1. So it is quite easy to know how to write and what is the meaning of sequence. If you call what is the series, so associated with every sequence, is a series. The indicated sum of the sequence, for example, associated with the sequence 2, 4, 6, 8, 10 is the series 2 plus 4 plus 6 plus 8 plus 10, and associated with the sequence minus 1, half, minus 1 by 4, 1 by 8 is the series minus 1 plus half plus minus 1 by 4 plus 1 by 8. This is called series. Okay. So now, oftenly in mathematics we denote with the help of the sigma notation. Sigma is, that is the summation notation. So the Greek letter sigma is often used as a summation symbol to abbreviate a series. So oftenly, if you want to write the number of terms, a large number of terms, and that is the series is a summation series, then we use this symbol always, and we write like this. So you know this. I can skip, just I wanted for the beginner. Now here, since we have already discussed about the sequence, then we must discuss the limit also. The sequence has the limit. A sequence has the limit L if for every epsilon, which is a very smaller quantity but positive, value capital N of small n can be found such that mod of n minus L, mod of n minus L is less than epsilon. Mind it, this should be very smaller. Epsilon is very smaller quantity but positive. For every n greater than r equal to, this is equal to also, the n is greater than or equal to capital N, then we may write limit n tends to infinity, an is equal to L. We may write like this, or simply we can write an tends to L, or n tends to infinity. So this is about the limit. Now there is one important aspect, that is convergence or divergence. So if a limit n tends to infinity an exists, it means this limit has finite limit. Then we say that the sequence converges. Note that for the sequence to converge, the limit must be finite. If the sequence does not converge, then we will say that it is diverges. So for the convergence, the limit must be finite. Okay. So note that a sequence diverges if it approaches to infinity. This is very important for numerical. Or if the sequence does not approach to anything, then we can say the sequence is divergence. Now, next important aspect is bounded and monotonic sequence. The bounded sequence, a sequence an, is said to be bounded if there exists a number k such that an is less than k for every n. And monotonic sequence, I think many of you are knowing, this is the +2 level course in mathematics, but just you go through very quickly. A sequence an is said to increase steadily or to decrease according as an plus 1 is greater than or equal to an, or an plus 1 is less than or equal to an. It means this is called monotonically increasing or monotonically decreasing for every value of n. Both increasing and decreasing sequences are called monotonic sequence. The monotonic sequence always tends to limit finite or infinite. Therefore, a sequence has monotonic and bounded is convergent. Okay. Now, if you go the mathematical definition of the series here at this level, at the UG level, then you must say if u1, u2, u3 up to un be an infinite sequence of real numbers, then u1 plus u2 plus u3 plus u4 all these values up to un goes to infinite is called an infinite series. So this sequence are called an infinite series. Okay, and an infinite series and denoted by summation of un, and the sum of its n term is denoted by Sn. So sum of n term is denoted by Sn. So in this way you have already defined about the sequence. Now next we have to study about the convergence, divergence and oscillation of the series. Consider the infinite series summation of un, and this is un, u2 up to un, this is infinite series, and let the sum of the first n term be Sn. Then Sn, of course, the summation of un means un plus u2 up to un. Clearly Sn is a function of n, and as n increases definitely under the three possibilities. So three possibilities, what are these possibilities? So if Sn tends to finite limit as n tends to infinity, then we may say the series summation of un is said to be convergent. If Sn tends to plus minus infinite as n tends to infinite, then the series summation of un is said to be divergent. And if Sn does not tend to unique limit as n tends to infinity, then you may say the series summation of un is said to be oscillatory or non-convergent. Okay, so we will look in the numerical problem all these series. For example, let us suppose you have to examine, this is a very basic series first problem I have taken. All are knowing the natural number, the summation of natural number 1 plus 2 plus 3 and so on, and you know the result. You know the summation is n plus 1 by 2. So how to write, how to check the series? So limit n tends to infinity, you check this. Sn is equal to, you may write half of limit n tends to infinity, n times n plus 1, and this limit, of course, that is tends to infinity. Okay, so you may check this and this sequence is already, this is visible, this is tends to infinity, hence the series is divergent. But here you look, test the convergence of this series, and the series is this 5 minus 4 minus 1. So you look, this block is 5 minus 4 minus 1, this block again 5 minus 4 minus 1, then again this block is being added 5 minus 4 minus 1. So Sn is this up to n terms. So this may be 0, this may be 5, this may be 1, according as the number of terms is 3m, 3m plus 1 or 3m plus 2. Clearly in this case Sn does not tend to a unique limit. अब इसकी तीनों वैल्यू हो सकती है, 0 भी हो सकता है, 5 भी हो सकता है और 1 भी हो सकता है. तो hence such series are known as oscillatory series. तो ऐसी series को हम क्या करते हैं? Oscillatory series कहते हैं. Okay. Now this is beautiful example, and you know all the students of mathematics up to +2 level they know कि this is beautiful series. और बहुत ध्यान से आप इसको समझेंगे, फिर से एक बार रिव्यू करेंगे, then at least one problem is already fixed here in this chapter in every university. So that the series is convergent if a mod of R is less than 1. So how? You look, this is Sn. Sn is already, you know, this is your geometric series. And the nth term also, you know, r power n minus 1. When a mod of r is less than 1, then limit n tends to infinity, r power n is equal to 0. And Sn, you know, that is 1 minus r power n divided by 1 minus r is equal to 1. And this infinite term series, so 1 divided by 1 minus r power n, 1 minus r. And the next you will get limit n tends to infinity Sn, then of course only the first term you will get 1 divided by 1 minus r, and therefore the series is convergent series because modulus of r is laying between less than 1. It means r is laying between -1 to 1. So here you know in this series r is already laying between -1 to 1 because as this is already given into the problem. If this is given into the problem, then it's, you may say that this series is convergent. Now this is for your practice. You must examine the following series: 1 plus 3 plus 5 plus 7 up to infinite series, 1 plus half plus 1 by 4 plus 1 by 8 up to infinite, 1 square plus 2 square plus 3 square up to 2n minus 1 whole square, and this is also infinite series. And then 1 divided by 1 into 2 plus 1 divided by 2 into 3 plus 1 divided by 3 into 4, and so on. And you have to do practice this series and check, examine this series convergent.